今日嘅 Live First Water Talk 海上建築工程安全而網上研討會正式開始。各位講者、各位來賓，大家好，歡迎大家參與今日嘅研討會。我係今日研討會嘅司儀 Phoebe。進行海上建築工程有別於陸上嘅建築工程，會存在特殊嘅安全風險，所以今日我哋好榮幸可以邀請到業主同埋顧問嘅代表同我哋分享。事不宜遲啦，我哋即刻將時間交俾中華電力有限公司項目總監李德明先生，同大家分享香港海上建築工程安全措施。有請李先生。
Okay, thank you for the introduction. Good afternoon, everybody. My name is Damon. I work for CLP and has been for the last 4.5 years or so, and mainly on one big project, although I did kind of work on a few others, but mainly on one big project, and that's where I would focus on the most of the issue from this particular project. So it's going to be in two parts, as been introduced just a moment ago. I do the first part, which usually is the easy part, and I've got a couple of specialists, Carl and Julie, to follow with the second part, which I'm sure you'll find very interesting. So without further ado, this is the items that I will talk through. What are the recent really so-called offshore projects in Hong Kong recently, and the job that I've taken most of the material from, which is the offshore LNG terminal. And from there, I will draw upon some key safety issues to discuss upon, and I'll draw some concluding remarks from there. This is a big offshore project, which, although the nature of it is actually extending from the near shore outward, so in most circumstances, you would actually would not call it an offshore job, but because of the scale of it and the number of vessels that we actually mobilize and the way that they are mobilized makes it more or less working in an offshore mode. So we have, for this ground improvement section, which is the first part of the undertaking, we are making a landform of 600 hectare of size. In doing so, with a short program, we actually had around about 33, 34 of really big barges. Some of them you can see from here, doing all the ground improvement works. And one particular issue with this job is that whenever we have a significant typhoon, what we have to do is actually evacuate every single vessels from here. Now you can imagine that with Hong Kong and the kind of shelter space that we have, which is not really catered for a big job like this, so we have to use all sorts of methods to try and find location to actually hide all these major vessels, which are all towed. They are not self-powered vessels, into hiding places during typhoon. And we had some really significant one during the course of the work. So that's one particular thing to note is that you see in the foreground a couple of these barges. They have a big block on the vessel, which is where the bridge is, and it's also where the accommodation is located. This is probably one of the first jobs in Hong Kong where actually a lot of the crew and the supervising people actually stay on board of the vessels during the course of the work. Obviously, they take shifts on and off, but they do actually live on the boat. This is the The job that I'll be focusing on, which is recently completed, started operation in early July. So basically the electricity that we are using here has got some contribution from the fuel imported through this terminal. It's a jetty which located off the southern part of the Hong Kong island. I'll get into a bit more on the location and so on the job a little bit. But I just want to introduce why on earth do we need something like that built in almost like a middle of the sea. Now, in Hong Kong, we have the pledge to go carbon neutral by the time of 2050, which is laid down by the government as a requirement. Now, it's still some way to go to 2050. And one of the important ways to try and cut down the carbon is to replace the existing coal import by natural gas. And we have been doing so for a number of years already. But the amount of coal being used is still significant, and hence using this terminal, importing LNG, will further cut down the amount of coal being used and replacing by natural gas. Don't forget, carbon production in a territory like Hong Kong, the majority comes from power production. We're talking almost 70% of the carbon production is from power generation. So dealing with these particular aspect actually goes a long way in helping the government to meet the intermediate target. So very, very important that we keep our pace along with what the government is trying to achieve. In terms of the natural gas that was being used prior to our terminal was something like this. For Hong Kong Electric, they have one pipeline from Da Pang, and that's actually an import LNG terminal, but it's a land terminal. It's not an offshore one. And for CLP, they have actually two pipelines. One is, which is the first one, from Hainan Island. So we're talking about pipeline of around about 700 kilometers all the way from Hainan Island to Hong Kong. The second one is actually riding on the maintenance effort of importing from west to east the natural gas, all the way from places like Kazakhstan, 西氣東輸. So we are able to tap into a part of that and branch it out to supply some natural gas to Hong Kong. So that was the scene before our terminal. This is the configuration that we have. So basically we have a terminal offshore, which is about 6-7 kilometers off the south of Lantau Island. It's in a very peculiar place in between a dumping ground and a marine park. There is a narrow corridor, which is where our terminal is located. And then from there, we have two not so long pipeline, but fair size. A 20-inch pipeline from the terminal to Lama for Hong Kong Electric, and a 45-kilometer one, 30-inch, all the way to the Black Point Power Station. Now, obviously, you can see the amount of offshore work that we're going to be doing is quite substantial. Apart from the terminal itself, we have to lay this long pipeline to the two power stations. Now, the Hong Kong Electric one is actually relatively simple, quite straightforward, whereas the one for CLP is one of the most daunting ones that you can actually find. For example, just quickly take you through this. Straight off from the terminal, we encounter 10 optic fiber cable, which is very important for Hong Kong, obviously, because they control all the data flow from international to the central district of Hong Kong, all the financial, and to every users in Hong Kong. So we have to put our pipeline on top, crossing all these 10 cables. But also we have to take into account of how would they, in future, build their future cable on top of our pipeline. So that's this kind of interaction has been one of the highlights of this job. Then we're going through the marine park and quickly to a TSS, a traffic separation scheme, which is like a marine roundabout with traffic going in all directions. A couple of, at this point in Fan Lao is known to be a lot of turbulence around with flow being quite unpredictable. Then going around the corner, we're getting close to Tai O, and as everybody knows, Tai O has a very sensitive community there. So conducting work has to be fairly careful there. Then we go through Hong Kong-Zhuhai Macau Bridge, and we have to go through in a section where the headroom is actually quite limited. And so we can't actually take the pipe laying barge across the bridge. We have to do something special there. Then we encounter another marine park where there's a lot of control. Further on, there is another marine park, and this one is particularly challenging, and because the very shallow water there. Sometimes shallow water is actually problematic as opposed to be easier. And then finally, wrapping around, or before getting to Black Pond, we have to go past Armstrong Road, and everybody knows Armstrong Road is a marine traffic hotspot where you have to be doing all sorts of temporary scheme to be able to actually get across to Armstrong Road. So fairly challenging pipeline to lay. So that's the terminal as we have constructed. On one side, this is what we call the FSRU, the floating storage regas unit, where basically it's primarily a storage vessel. It can store 260,000 cubic meter of LNG. On the other side, we actually allowed a berthing of the LNG-C, which is a carrier that delivers LNG to our terminal every now and then we transport the LNG across to the storage boat. The FSRU has regas facility and before sending out the gas to the two terminals. So that's how the terminal operates. So very quickly going through some names and so on. The client party is CLP, working under the name of Capco and Hong Kong Electric. And because it's a joint venture, so there's a terminal company set up to handle the joint venture issue. The contract is an EPC contract. It was eventually, after tendering, awarded to COAC, Zhonghai which is a mainland international offshore company. They have a local designer for them to go through all the local issues, which is Arab. So the work, the contract commenced in early 2020, and as I said, the operation started on the 3rd of early July this year. Okay, so much about the job itself, and there's a lot more to talk about if there is time. But I want to go straight into some safety consideration. I've been working on the marine environment in Hong Kong for some time, and long enough to let me realize that there's something that we, I think, jointly have to get more prepared in order to tackle further offshore marine works in Hong Kong, so that we can get well prepared, look after the safety aspect of it. So these are the items that I picked out as something that I have personally been through and thought that it's something that I want to share and hopefully arouse a bit more discussion in our industry. Oops. Okay. The first one is design. Now, actually, I start from design, but actually I could have started from even before if I want to. For example, on the site selection, for example. Site selection is actually a very important aspect of making sure things can be done in a safe manner. But I don't want to go into that aspect because it opens up a lot more disruption. Whereas I will start as something that's been decided that we need to build. And first off is how to actually make a good offshore design. Now, when I first took on this job, the top diagram is what the piling layout is. Now, as you can see, this is all tailored as very typical Hong Kong kind of project, where they use off-the-shelf piling sizes, readily available. So these are in short segment, 12-meter length, and etc. There's a lot of on-site working, and this is something that we must try to avoid as much as possible. So the first design change was made to the one below, where we dramatically reduced the number of piles, which is you can judge by the number of red dots here. And in doing so, we go out of the norm. So we're talking about pile diameter of about 1.8 meter diameter. We're talking about rolling steel sizes of 50 millimeter thickness, which makes it quite difficult. The first segment of the pile is like 70 meter long, and the second one is about 20-ish meters. So basically, we have only one on-site weld that we're going to do. So all this is geared towards trying to have the minimum time spent out in a hostile environment out in the sea. So that is the key consideration. And the other point is that in usual, these are all friction piles, by the way. Even though they are 90 meter long, we are not actually chasing down to rock head. We're actually trying to develop enough friction. So in a normal sense, you would actually need trial pile and then loading tests and etc. In offshore environment, we can't really do that. Some interaction with the governing bodies to ensure that we actually have a way out and still demonstrating it's a safe design. Draw upon a lot of international practice. The second important aspect, as far as I can see it, is on the offshore experience. And I say that with no exception that we need somebody who knows what they're doing. And this is where Carl and Julie comes in. And Carl was involved on this job way in the early pre-FEED stage. And we were discussing a lot of issues during the tender preparation stage into tender evaluation and etc. And eventually, Carl actually stayed and most of the time in the sea or on the boat and help us to making sure that everything is done in good order out in the sea. So I'll let them talk in more detail later on after this. Boat transfer. Once we have a job, we have the design, and we start construction. First thing that we look at is how do we, what are the most risky thing for our construction worker and for our supervising staff and etc. and it points to, based on offshore experience, people transfer. And a couple of clips will probably let you realize what we're talking about. So in a normal day, this is what you see. You have a landing there, and the boat is rocking around. But in quite a lot of the cases, this is what you will see. And imagine yourself being on the boat here now and trying to get off onto the jetty. This is what you would encounter. Do you feel comfortable getting on like this? That's the question that we all have to ask. There is another mode of transferring people, which is what we call the Billy Puge method, which is used a lot in the offshore industry. Basically, it's a cage lifting, and with a bit of training, it's quite easy to do, but you do need to know what you do and don't when you are on a transfer system like this. Hong Kong has not got really any good regulation to look after transfer in this kind of mode. So it's something that I think needs to be introduced in a more systematic way. I mean, if we go in full mode, where you have a lot of on and off to do, then you might go for something more dedicated like this, where you have a motion compensated gangway, where you basically walk fairly steadily across from one to another. Now, this is obviously to the upper extreme if something that needs to be done very often. Hong Kong is not actually got nothing to start with. We have this provision from kind of a code of practice from Marine Department. So for pilot boarding and so on, these has been covered. It also talked about steel cages and things like that, which I think is something that we need to probably discuss amongst the industry user as to whether this is a good option for construction, bearing in mind that workers carry stuff and etc. And as I mentioned, Billy Puge is the very well established industry method, which should be introduced in a more systematic way. Okay. The other one, which is quite related, is that on land we always work and then go home, because Hong Kong is not a big a city. We can always get to work and then go home in a reasonable time, and we have the odd overtimes and so on. But on a marine environment, as I mentioned, how do we actually cut down the number of access on and off the boat? And bearing in mind that because we are in the offshore environment, we have less restriction on the time of working. So quite often the contractor will opt to go round the clock, also to minimize the duration of the work as well, which is obviously introducing risk to the project if we are staying out in the sea longer than necessary. And so all this combined together means that there is a scope for looking at a different working kind of arrangement. People would actually go on board. My project team's supervising people also actually adopt this way. They actually go on board the vessel, stay on board for 2-3 weeks, usually. Contractor usually stay longer, but we actually adopt a shifting around of 2-3 weeks. And then allowing them when they get off the boat, they have a longer off duty time. So that way of working dramatically reduces the number of getting on and off a boat occasion, and that helps to cut down a lot of the safety, safety concern. Now, in order to actually provide this, facilitate this, we need boats that are well equipped. So this is one typical one. This is probably not the best facility, but it's a typical one where we got gym, we got cinema, table tennis, and obviously meeting room, canteen. Sometimes you will find that when a contractor comes from, for example, the northern part of mainland China, you get a lot more spicy food and all that, and so sometimes it takes them a little time to actually get more used to getting the local kind of flavor. And you have laundry places, and you can do a special festival, and then you have a bit more, etc. So it's quite typical for bigger barges like this. Okay, the switching to a fairly different topic, diving. Now, ever since I've started working, we have looked at diving in Hong Kong, and in the early parts, it's kind of quite mixed. Some are quite extensive, but some are just off the kind of like you've some diving activity needed. They would just like call upon some company and then just come and do some work quickly. And the kind of control is actually quite variable. Now, in the last couple of jobs, we've been actually introducing a lot more systematic and stringent way of working. So no more of the kind of petty qualification. We go for the IMCA, which is a very well-established contractor association kind of method and procedures, it kind of asks for a lot more organizing and making sure everybody's qualification is up to date with continuous training and etc. So there's a lot of managing to do to actually get the diving in a more systematic and a more controlled manner. So this is something that we've made sure of in the project. Carl may be going into this a little bit. So in a typical example is that our diver will carry a transponder down to the diving location. So all the time, our supervisor on board would have known that their exact location, their movement, etc. And then the controller can communicate with them and making sure that they get the instruction, they get the feedback, and etc. And I think on top of that, CLP actually introduced a bit more requirement than what is required by IMCA, and that is to actually make sure that every single occasion for diving is discussed, whether it's necessary and can it be replaced by something else, which is usually called upon with technology using ROV. And this is developing quite fast. There's a lot of institute actually developing more capable ROV to do the work. And it's important to realize this is not actually to completely replace diving, but it's actually to come kind of help the diving to actually do a more safe and better job. So in terms of technology, the old days we have small ROV like this where they drift around and can't easily be controlled. So these are obviously not suitable ones that can do the job. But we also have this type where you send the ROV down and it's got a cutting disc actually to actually do a robotic action for some heavy duty works. So they can do this quite easily nowadays. Drones technology, I won't go into too much detail, but because of this development of drone technology, there's a lot more that can be done. It can carry a lot of different high-tech equipment, can even do kind of LiDAR scanning. So there's a lot more that we can do with technology these days. Okay, coming quite close to the end, local legislation. There's quite a lot to talk about on this topic. Now, the regulations for marine or offshore work is that there's very little, and it's actually not well put together. For example, on people's training, all our people, when we go to site, we are supposed to actually get as opposed to the green card, we have to get the blue card. But if we look into detail of what is covered in the blue card training, you will realize that it's not actually targeted for construction industry. It is actually for the container operating industry. So we think the blue card is important, but important in the sense that we have to actually try and influence that to actually cover some part of training that is going to be useful for our construction people. This is actually very important. And when I talk about legislation and so on, one particular example is the use of gas. There's a lot of work out there using welding and so on, so it calls upon gas cylinder. And this actually has caused quite a lot of confusion on our job as to what is actually allowed on vessels. Now, if we are not careful, actually we can get into a lot of difficulties with this. So I won't go into too much detail, but it's something that I think for long-term contractors and designers and the like needs to try and push for more clarity from the governing body so that we don't get into problem later on. Okay, just to conclude very quickly, we shouldn't really just adopt a land approach and then extend it to the marine. This is not something that we will promote. We need to look at it fundamentally, what is the risk in the marine environment, and trying to actually work out something for that. Governing bodies, there's a lot to do with the guidance and design code. I think one particular aspect is the coordination or collaboration between construction industry and the marine industry. There is not a lot interaction nowadays. We only call upon services of the counterpart, but there needs to be a lot more getting together to work out better methods. And last but not least is to build a culture of a marine environment culture to look at how our safety should be dealt with. I probably have overrun a lot, so apologies for that. I'm just too keen to get the messages through, so I'll stop here. Thank you.
唔該晒李先生嘅分享。接住落嚟有請 HRE 嘅代表 Miss Julie Hillier and Miss Carl Hillier 同大家分享海上與岸上建築工程嘅慣例同埋安全措施。Please welcome Julie and Carl. Thank you.
Thank you, Damon, and thank you to the Construction Industry Council for the invite to speak today. We are HRE Consulting, a husband and wife team, and between us we have over 70 years experience in oil and gas. He has more than me, I'm the young one. So today we're going to talk a little bit and build upon what Damon mentioned in terms of reframing safety at an industry level and making sure that we can actually give the workforce at grassroots the tools to be able to provide their own safety leadership in that construction environment. So we'll talk about some of the technical aspects. Carl will talk to that, and I'll talk to some of the psychology and the neuroscience of safety leadership and safety leadership. So just to quickly introduce ourselves, I have over 30 years international experience. I worked with Shell in the UK and Europe on offshore oil rigs and gas plants, specialising in leadership, development and safety leadership, and making sure that was underpinned by psychology and neuroscience. I've had the opportunity to work across the UK, in the US, Mexico, Norway, France, the Middle East, Singapore, and also jointly with Carl on the project, alongside Damien and his team onshore and offshore. I also have designed many of our RU Safe 360 programs in conjunction with Carl. Carl focuses on the technical components, and I look at the neuroscience and the psychology of that. And we base that on working very much and partnering with the industry and the client and the contractor to co-design. So we use human-centered design, and I've also lectured at Stanford University at their School of Engineering on using co-design to actually make sure that we apply practical and science-based safety leadership and leadership tools across the whole workforce. I'll pass over to Carl to introduce himself and then take you through some of the technical insights that will build and complement on some of the work that Damien's just covered.
Thank you, Julie. Yes, I'm the older one, but I started in this industry when I was quite young. So I'm still young. I worked in the offshore and onshore construction industry for a long time, and it wasn't until I recognised that the industry needed a safety culture that was consistent across all countries and disciplines and cultures. And so between Julie and myself, with Julie's neuroscience background, my technical background, we developed Safe 360, which is a culture that can be taken across the world to different cultures and quite easily embedded therein. The first thing I want to talk about, as we said, is the safety case. So some of you may be familiar with the safety case. The safety case came into effect straight after the Alpha Piper disaster in the North Sea, and it was a recommendation that one of the biggest recommendations was for people to and companies to engage a safety case. And it wasn't. It took quite a while before Australia actually took hold of the safety case, and it took many years to actually develop it into what it is today. And I know for a fact, growing up in that industry, the safety case grew and grew to a point today where it's something that no operator can come into a facility or a project without having a safety case. And the reason I point this out to you today is that you may see it relevant to introduce into your industry in whatever form you'd like, but it's something that will hold vessel owners accountable, projects accountable, and it'll also give you a means of tracking a project and learning from it and then expanding upon that. I won't go too much into it, except to say that there's a webinar on YouTube. There's a link there. It's worth watching to understand it a bit better. This slide just demonstrates the life cycle of the safety case and how it's a continuous improving and learning exercise. And it's for me, it's been really beneficial in my journey. So the next thing is safety at the coalface. I know we all talk about safety. We put in a lot of effort into having procedures, regulations and everything else, but the safety is really driven at the coalface. If you haven't got that right, then you actually struggle to keep hold of a safety regime that's what you set out to do. We work with different countries and different cultures, and we often get asked to have different components brought into it. And one of the components is situational awareness. So this is a project in Ensenada in Mexico. So we went to site and did all the observations, and so on the left-hand side you'll see there's a wheelbarrow with a large bit of steel that the local contractors were moving, and on the right-hand side you see a bobcat, a machine carrying tins of paint, and the situation here was that there were two different contractors doing two different things. If they swapped over, they would have made the place efficient and safe. So it's just an example of situational awareness. So situational awareness is there's 4 levels, and in the training that we do, we focus on the middle 2, which is focused awareness and relaxed awareness, which gives you a proactive result through thin slicing. So what I want to talk about here is the local vessels and the high level of awareness between contractors being in direct control. What this video will demonstrate that in the industry in Hong Kong and on the project, we had different levels of awareness. We had some contractors who were quite well geared up in their safety regime, in their safety mindset. Some were still getting there, and then there was others that really need help. And on the project, what we did, working with Damon, every time we came across this issue, we stopped, we tried to re-educate the people and change the way we were working to a point where we did start working safer and efficiently. So this contractor here, high level of safety focus. The guys had barricades around the equipment, and then you had some local contractors that were almost there. They had all the safety equipment, life jackets, and that kind of thing. And then you had other people that turned up with their vessels that were actually not suitable. They turned up with, as you can see, unaware of the safety requirements for a construction site, and eventually we had to re-educate them as to what offshore requirements were, and they soon became more and more compliant with our safety regime. Vessels, this is where the safety case will come in handy. The vessel turns up with broken rungs like this and expect to climb up missing rungs. Again, the safety case would have made sure that these kind of vessels did not turn up. This was one of the barges that came with pipe on board. We took all the pipe off and there was holes in the deck where people could quite easily have fallen through. Again, if you hold the contractors, vessel owners accountable through the safety case, you'll start to get good control on these situations. Crew transfer, as Damien pointed out, one of the big reasons we avoid crew transfers is to make sure that on a calm day everything's nice and fine, you can transfer over, and then you get something on a day like this. There's obviously we do the transfer, but it's still a bit of a risk, and as you'll see here, it's also the understanding of the people that are transferring as to their own safety, and if they don't know what they don't know. So it's up to us to educate these people as to why we wear life jackets, why we time our transfers over from vessel to the boat landing, and why it is that we have. As you can see here, he didn't understand the concept of a life jacket. So again, that's an educational thing that we'll go on. I actually took this video coming in. I stood on there to give people a really good feel for what the dynamics are between a vessel that's stable and a crew boat trying to bring someone alongside. It just doesn't work. And however, the vessel is stable enough that you could do a billy pew transfer from one stable platform to another. And of course, again, we did a lot of training on the job all the locals that have not got that experience. So it was a time where we were actually developing the offshore team on the job training, if you like. Damien mentioned about the diving IMCA standards. Now here's an example of how well the supervisor, as you can see, he's going between the screen on the right and on the left is the diver's video from his camera, which you can't see nothing, and he's actually guiding him, telling him exactly where he is on that pipeline, and the diver has a pinger on it, and you'll see in a second. There's the outline of the pipeline, the jacket, and then you'll see that he's tracking the diver as he goes along. This is international standard, and this is something that we brought onto the job. We insisted that the contractor employ IMCA certified, qualified people with the right equipment. We did all the audits, and then we ended up with the safest possible utilization of divers on the project. In this one here, we talk about the dynamics, the wave period, and as you can see, it looks like a perfectly good calm day. But this vessel, unfortunately, the natural frequency matched the wave period, and she was unable to work when others would think, why not? It's nice and calm. So that's something, again, that we use in the technical safety training, where we talk about vessel periods and calm conditions and how it can affect. So this video here is a different job where a similar situation, the wave period affected the lift, and ultimately the crane driver gets to have to put it in the water. In comparison, where the swinging happened, it's actually happened on our job in Hong Kong as well, where the crane picked up a bank of bottles, gas bottles, and also it was swinging out of control because of the wave period of that was affecting it. Here it is back to a different project. They end up having to put the lift in the water to stop it from moving, and it's the only way you can control it. There's no other way. You cannot bring it onto the deck. Again, back to the project. That's what happened. Had to go back in the water to stop it from moving. So that's all and good. You can do that to something like that. But if it was a sensitive piece of equipment, and it has happened in the industry, we put it in the water, and the project's delayed by many, many months because that equipment is no longer useful. So it's very important to focus on the vessel of choice, the location, and do a lot of work on technical safety of that vessel. So when we talk about, I won't go too much into technical safety here, but to just say that I know we talked about the blue card training. In one of our components for our gold card training, we have technical safety, which is just as important as anything else, because it actually gives people a bit more understanding about what actually happens, what the consequences are, etc. Just an outline, some of the slides that we have in our technical safety. We talk about dynamic application factors and formulas and things like that. You need to teach the people a bit more than telling them how to put a sling on the crane, and you need to tell them what happens when things start moving and the dynamics involved in this. So what I'll do is I'll hand over to Julie to talk you through the powers of observation and the neuroscience and psychology on reframing safety.
Thank you, Carl. So Carl's covered some of the things that can happen from a technical component that can impact on safety, and particularly in the offshore environment where there are a lot of variables and it's a really dynamic, fast-moving situation. Where we also focus on is actually the workforce themselves and making sure that they actually have the tools to be able to reframe their approach to safety so that we can have that consistency, and then we do a collective uplift of the standard and have people operating at the same level of safety. So one of the things that we look at is the neuroscience of self-leadership and self-leadership in safety. And I just want to show you a really short video that demonstrates this really well. So in this video, we're going to ask you to count how many times the players wearing the white t-shirts pass the ball to each other. That's your task. So I'm sure everybody online has got a number in their mind of what they think the answer is and how many times those passes happened. Let's see if you're right or wrong.
12. High, low.
Okay, we have some guesses in the room, maybe 12 or a little bit higher. Let's have a look. So 16 is the correct answer. We would then ask, did you have any other observations? Did you notice anything else happening in the video? Did anybody spot anything different? A gorilla, okay. So some people spotted the gorilla. What we know is, from a psychological perspective, that sometimes less than 50% actually spot that gorilla. We also then go on to ask what people noticed in addition to the gorilla. Did anybody else notice anything else? For those of you online, did you notice anything about the players with the black t-shirts or anything about the curtain? And what also happened in that video was one player from the team with the black t-shirts left and the colour of the curtains changed. We'll just rewind and show you the video again. There's the gorilla. There's one player leaving, and the curtains change colour. So why is that relevant to safety leadership in the offshore environment or onshore construction environment? What you've just observed and probably experienced is a psychological phenomenon called unintentional blindness. So we only see what we consciously or unconsciously program the brain to look for. So we had programmed the brain to count the number of passes between the people with the white t-shirts. And because they had that single focus, many people miss the gorilla. They also miss the curtain changing colour. What our Safe 360 programs do is actually reprogram the brain, so the whole workforce is also looking out for the other factors as well. When we designed Are Safe 360, we wanted to make sure that it also was complementary to the good work that was happening with many of the contractors and companies, and we make sure that it complements, that it's inclusive, and it's also really simple, so it can actually be done through sign language when you're in that really dynamic environment. I'm just conscious of time. We've only got 5 minutes left, I believe, so we might just skip through the next slide and the next one, Carl. What we aim to do through the training and the Are You Safe 360 training is take the culture uplift of an industry, and that can be done at industry or workforce level up to the mature generative safety culture. And this is based on the international maturity and safety culture continuum as well. Carl, I'll just pass over to you to finish off from a time perspective.
Okay, so the most satisfying thing we got from this particular project in Hong Kong, one of the first of its kind, was that we were proud to be a contributor in terms of safety to the 14.5 million, as Julie says, not man hours, people hours, neutral, gender neutral term. It was a time where and all credit goes to Damon, who insisted that we have this program embedded on the project, and of course with my colleagues out there with the team, we actually had a really high level of focus on this. Now, what we do in our training, it's unique, it's different for others, and young Alex and David can confirm this. We actually took real situations that were happening, and we got the teams there every Sunday night, and then during the day on the job we walk around and we actually teach them how to change their habits. And I'll show you this video, which is something that really made everyone sit up and think about safety. So what you'll see here is it's actual footage of the crew returning from the jetty to the accommodation barge. They were coming in for lunch, and generally they like to get in early, get their lunch and have a rest before they go back. So and as the vessel was approaching, they were concerned about the anchor hanging down where it could collide, put a hole in the barge. That was the captain looking out, and everyone else, all they wanted to do was get off and go to lunch. So while doing that, they put themselves at risk. You will see here that people were just jumping off, almost falling backwards, had no concept of the consequence. And this is what we do in our training. We use real situations in the workshops that we have. And when people see this, they definitely change their attitude towards safety when they know how close they came to actually getting hurt. And this is far more effective than talking about a situation, is actually showing them what will happen. You'll see here in a second a guy coming through and actually steps between two tires that are moving. Because he's trying to get off as well, and he almost gets his leg caught because the tyre, as we all know, the tyres move and push up. He almost got his leg caught in that in between the two tyres. So again, this is something that we do continuously and have done on the project. Here we'll just go through the gold card. There's we work through with the industry. We work through to whoever we're dealing with, and we actually tailor it to suit your requirements. So I'll let Julie talk through this last slide.
So we use a science-based methodology to create transformational change or transitioning an industry or a workforce or an individual to reframe their safety. So we hope what's been offered up today between Damien's insights and Carl's technical insights and just some of the neuroscience and psychology, that we can all work together collectively, and each country is looking at how they can reframe their safety to constantly uplift the culture that's so important. And if we can have the right vision, we provide the right skills, the resources can come from many different sources and have a clear action plan, then we have a science-based opportunity to actually create significant change and transform the culture that we all want so we can all go home safe to our families every day. Thank you very much.
Thank you, Judy and Carl。亦都要再一次唔該晒咁多位海上建築工程嘅講者分享，相信大家對海上建築工程嘅安全了解多咗，同埋亦都加深咗。希望大家可以緊守安全，特別係喺海上建築工程嘅工友，記得要做好安全措施，防止意外嘅發生。而有鑑於最近嘅吊臂車吊臂塌下事故，我哋今次嘅 Walk the Talk特別邀請咗義力工程顧問有限公司董事林偉權工程師為大家分享。佢將會分享嘅題目就係使用及操作流動吊機需要注意嘅安全事項。有請林工程師。
大家好，午安。我叫林偉權，係義力工程顧問公司嘅嚇。咁我今日想講嘅題目呢，就係點樣去使用同埋操作呢個流動吊機，我哋需要注意嘅安全事項。咁其實我哋喺安全操作呢個吊機呢，其實最直接嘅呢，我哋就一定要定期檢查啦，同埋更換嗰啲損耗嘅零件啊。咁亦都係咧，我哋要確保我哋知道嗰啲吊重物，因為而家嘅建築機械好或者其他嘅機械咧，都越嚟個越重型啊嚇。咁所以我哋一定要知道佢個重量，同埋咧嗰件物件嘅重心啊，咁我哋先至可以吊運嘅嚇。喺重型嘅吊運之中咧，同埋喺啲繁忙嘅地盤咧，我哋一定要由嗰啲吊運監督或者係佢嘅信號員去預先了解個環境，即係咧，譬如我哋要睇下四周圍咧有冇其他嘅物件啊，有冇人啊，或者如果係重型吊運咧，我哋一定要圍住佢啊，即係唔好俾人行埋嚟，咁先至可以去叫個機手去吊運，咁樣先至係比較安全嚇。好多時喺啲繁雜嘅地盤咧，往往咧就忽視咗喺啲有啲盲位啊，我哋叫做就當佢轉動啊，或者啲物件轉過去嘅時候咧，就會產生意外嚇。咁其次咧，喺安拆一個吊機嘅時候咧，我哋最緊要咧就係跟足嗰個施工方案，同埋有一個合資格嘅監督人員咧係去指揮係進行嘅。咁而係咧喺一啲經常發生嘅咧，就係一啲土壤比較腍或者鬆軟嘅地方去吊運咧，咁嗰部機咧就容易會雜質㗎啦。咁所以咧，我哋首先咧就要確保嗰個地下咧就要係比較實淨而係安全。咁如果有需要嘅咧，就最簡單咧就係鋪鐵板啦，或者而家有啲譬如房署嘅地盤啊，或者係有啲大型嘅地盤咧，就要求咧就用啲混凝土板去鋪咗個地下，先至俾啲吊機去操作嘅。亦都有如嗰啲油壓吊機啊嗰啲，我哋咧就會有啲纖維板比較輕身啲，去分薄嗰個承托力嘅嚇，咁樣係確保嗰個地下嘅唔會沉坐落去嚇。咁喺地基嘅鑽挖工程之中咧，就我覺得咧，因為我都唔係一個土木工程師啊，就係最好咧，就係喺嗰個了解嗰個探討報告，知道個地層嗰個即係地質嗰個方面嘅嚇。咁點解咧？因為好多時咧嗰個鑽機咧，即係我哋喺大型嘅鑽孔啊，或者係小型嘅鑽孔咧，都會嗰啲風咧都會令到個地層咧就係會流失嘅嚇。咁樣喺呢個情形之下咧，亦都會導致嗰啲吊機當佢吊運嘅時候咧，就會睇唔到咧，就會產生意外。 或者沉咗落去。咁而家咧我就利用以往嘅比較常見嘅吊機意外咧，就同大家分享下嘅。咁喺呢個圖之中咧，我哋見到有部吊機嗰個吊臂咧就會下塌咗落嚟。咁其實咧就係呢個我哋喺一個近距離攝影得到咧，就係嗰條我哋叫起落接嘅威亞嚇，即係呢個吊臂威亞咧就係斷裂咗嘅。咁而係喺呢個情況之下咧，喺個意外調查咧就發覺原來佢用咗一條唔適當嘅即係威亞，即係我哋叫做鋼纜啦嚇。咁所以咧喺呢個情形之下咧，我哋要確保我哋要利用嗰個廠方要求嘅威亞嘅鋼纜嚇，就唔好立亂話係譬如20 mm 嘅，咁我就買一條20 mm 嘅鋼纜就算數啦嚇。一定係要確保係廠方合規格嘅鋼纜亦都係要長期咧即係加潤滑油咧，即係等佢咧就唔會容易去生鏽或者係損耗。咁呢個咧就關於嗰個磨損啦，同埋折斷啦。咁如果吊機有時咧，我哋要好小心嘅時候咧，就係譬如有啲地盤，我哋真係要好長時期工作，或者甚至而家我哋有好多地盤咧趕工咧，就甚至咧就開到24小時嘅時候咧，我哋要經常咧就要去檢查啲鋼纜嘅情況啦。咁如果佢一有磨損或者係幼細咗咧，咁我哋就要更換啦。咁而家咧，如果根據我哋勞工處個規格咧，就係如果一條鋼纜佢比佢正常嘅直徑細咗5個 mm 嘅時候咧，我哋就需要更換㗎啦。但係喺我個人嘅經驗之中咧，我覺得當佢細咗3個 mm 3% 嘅時候咧，sorry 係用 percent 去就已經要開始要更換啦，因為你唔會有某啲情形之下咧，你唔知道下一次你嘅檢查係幾時㗎嘛，咁所以咧就細咗3% 嘅時候咧，就應該要安排去更換。係，但係大家亦都要緊記嘅咧，呢個3% 咧就唔係指，譬如我哋睇個說明書或者個 catalog 咧，入邊話係20 mm， 佢就係20 mm。我哋係要以佢新買翻嚟嗰條鋼纜嗰個直徑為標準嘅。譬如有啲情形之下咧，一條20 mm 嘅鋼纜咧，佢可能買翻嚟係21 mm 或者21.5 mm， 咁我哋亦都係以呢個為標準嘅。咁除咗吊機嘅零件或者佢嘅損壞令到佢產生意外之外咧，就係我哋常見咧就係失平衡。咁失平衡嘅最主要原因咧，第一咧就係吊嘢過重啦，或者係吊一件好重嘅物件個轉運個速度太快啦，咁就產生呢個離心力。咁第三咧，我哋就係吊運不平衡啦，或者係嗰件物件即係我哋攞唔到個重心，或者係嗰啲吊索唔穩陣線啦我哋即係會線尾啊。咁第四咧，我哋就係個地面嘅承載力唔足夠咁第五咧，亦都係咧就係個地下咧就曾經俾人哋或者係掘開咗填翻嚟但係填得唔夠實淨呢個情形都幾普通嘅。第六咧就係譬如我哋做一啲波派大口徑裝或者係迷你裝嘅時候咧，嗰啲風量太大，而係令到下低個水壓下沉或者係嗰啲泥土鬆脱或者係啲泥土即係啲土咧就走咗去第度嗰啲。咁吊機嗰個平衡嘅安全設定咁而係一部吊機，我哋點樣為之佢係平衡咧？咁如果喺個設計一部吊機嘅時候咧，我哋除咗佢本身嗰個結構之外咧，我哋咧就係如果我哋睇佢個吊重表咧，佢通常咧就會話75% 落去個 tipping load。tipping load 咧就係 tipping factor 咧，就係佢部機開始反機嘅情形嘅75%。咁即係咧，當吊一部 吊運嘅時候咧，佢嗰個力矩啊，去到失平衡嘅時候咧，嗰個廠方咧就以呢個數字嘅75%咧就製作佢嗰個吊重表啦。即係譬如好似喺10米嘅範圍咧，我哋吊60噸咁樣嘅時候，佢會失平衡嘅話咧，咁喺個吊重表咧，佢就會乘翻一個0.75變咗45噸啦。呢個就我哋叫做安全係數。乜嘢叫失平衡咧？如果喺一個履帶吊機嗰個時候咧，我哋咧就會發覺由佢嗰個鏈板對落嗰啲轆啦嚇，開始離開個鏈板嘅時候咧，我哋就已經叫做失平衡㗎啦，就唔係話成部機開始離地嚇，一邊離地。而係一個輪胎吊機，佢係開咗4隻腳嘅時候咧，就其中有一個隻腳咧，佢嗰個地下個墊咧就開始鬆嘅時候咧，我哋就叫失平衡啦。咁例如咧喺我哋測試嚟計咧，我哋咧就係當佢開始離開嘅時候咧，我哋就會試下隻腳，譬如揾隻腳去踢下去嗰塊底墊喐唔喐啊，或者係有冇離啦咁樣，咁啊已經係叫做失平衡啦。咁以呢個數字嘅75%咧，就係我哋嘅安全負荷啦。嗱，呢度大家睇得到咧離心力啦。其實離心力咧，大家就等同咧我哋去玩迪士尼啊，或者去海洋公園玩啲旋轉嘅機械咁樣。咁你見啲小朋友或者大家咧就會 V 哇哇咁。大家要明白咧，當你喺重心嗰時候嘅轉動咧，同喺譬如10米以外嘅轉動咧，嗰個速度咧係有個偏差嘅。咁所以往往咧喺個司機個座位嗰度，佢將部吊機轉動嘅時候咧，喺10米以外嗰件物件咧就會轉快好多啦。咁呢個轉快嘅情形咧，就係大家咧就譬如咧，我用一個德國 Lipia 嘅吊機嚟比較咧，咁佢個速度咧可以去到1分鐘咧就係3.5個1分鐘可以轉3.5轉嘅嚇。咁佢個離心力咧，即係大家喺個圖片嗰度睇得到咧，就會即係向外嗰度咧就走咗出去啦嚇，最遠可以走到2米以外。咁嗱，呢個咧就係因為吊重嘅離心力，而係導致嗰個吊，即係嗰件吊嘅物件咧就失去平衡，咁成部吊機咧就趌起個尾部嚇。咁呢個咧都係一個意外個案嚟嘅嚇。咁另一個個案意案咧就係呢個咧就純粹咧就係個地下不平衡而係坐低部機啦。咁亦都唔係話當其時嗰啲地盤工友咧睇得到個地下唔平，而係當佢喺某一邊受力嘅時候，而係下低個地下係啲土壤淋咗啊，或者係失去咗啊，而係導致部機咧就坐咗落去。咁呢個坐咗落去咧，令部機咧當佢如果係吊緊重嘢嘅時候咧，咁佢就會反向另外一邊。咁嗱，呢個少少嘅圖片咧，呢度解釋咧就係一個大口徑裝嘅我哋叫做反循環嘅轉向。咁一個大口徑裝嘅反循環轉向咧，佢係靠風咧就將地下嗰啲沙泥啊各樣嘢咧，就係經翻個轉桿就吹翻上去嘅。咁但係當佢轉啲比較譬如好似石啊或者石層比較實嘅地方咧，就冇問題。但係如果轉啲比較鬆嘅泥啊，而係將周邊嘅泥土咧，就係用啲風咧，就將佢即係吸咗上去啦，即係我哋叫塞順啊嚇，即係吸咗上去嘅時候咧，就變咗造成入邊有個空間喺度，咁變咗上邊嗰啲泥咧就會淋身咗。呢個咧就係我哋叫做地炮啊，即係我哋通常咧就叫做 down the hole hammer 嘅一位。咁呢個咧就個情形咧就比較更加啦。當呢個地炮去轉落去一啲石層嘅時候咧，就唔會有問題發生嘅，因為佢倒咗石。但係當佢轉落去啲泥嗰度咧，佢就會將周邊嗰啲 嗰啲風咧就會令到啲泥土咧就鬆脱啦嚇。咁喺啲大家見到兩種顏色咧，埋身嗰個咧就係一啲比較硬身啲嘅泥土，開邊嗰個咧就腍身啲嘅泥土，咁即係會鬆脱得會更多啦。咁所以咧呢個係靠我哋咧係控制個風量去處理嘅。咁喺我哋講咗咁多咧，就係總結嚟計咧，我哋吊運安全咧就唔係只係靠個司機嘅，係要喺個工地嗰度咧係要靠各方面嘅風險評估啦，嚇，同埋做一個適當嘅預防措施啦，譬如墊好個地啊，或者知道啲物件點樣去預早知道啲物件嗰個重量啊，嚇，多謝大家。
唔該晒林工程師嘅分享。最後，我哋有請建造業議會建造安全總經理林永東先生為大家致閉幕詞。有請林先生。
係，大家好，咁我係 Tony Lam 啦，咁就係 Head of Safety。咁今日點解會我講閉幕詞咧？大家可能都即係期待住我哋主席會睇下有啲咩講。但係主席今日可能咧，因為個聲唔係幾好啊，咁講唔到。咁等我做個 closing。咁咧首先多謝阿林工程師先啦。咁嚟咗我哋即係呢個 webinar，咁同大家講解下嗰個吊運個安全。咁唔係貿然我哋邀請阿林工程師嘅，因為喺對上嗰個禮拜，大家都知道都有一單意外，就係有個鏈帶嘅吊機啦，就反側咗啦。咁林工程師頭先都講咗好多唔同嘅即係原因，好多因素啦。咁我諗即係業界大家都即係面對到好多唔同情況嗰陣時嘅安全問題，大家都要留意嘅。即係而家出咗一個咁嘅意外啦。咁所以即係我哋唔係好知道即係真正嘅原因。咁但係即係阿林工程師都講咗好多。咁另外亦都好多謝中電啦。咁thank you very much for coming, Damon, Julian and Carl for sharing all the offshore construction safety. So I think this is good because sometimes we just not realize some of the project that is actually happening in Hong Kong, and there are a lot of safety concerns that we need to address. So thank you very much for sharing. 咁咧今日嗰個 closing 其實大家睇到畫面啦。其實上個月嘅 Walk the Talk 咧，咁其實大家都知道我哋係講咗嗰個關於電力安全嘅。其實好不幸啦，喺上個月到今日為止咧，其實發生咗2宗嘅電力死亡事故。咁呢啲大家都唔想見到嘅，但係真係好不幸。我哋上次講完嗰個題目，啱啱溫故知新，咁就又2單死亡事故係關於電力嘅。咁即係大家業界即係真係要加把努力，點樣可以睇好我哋嘅安全啦？除咗呢2單死亡事故之外，喺8月份其實我哋都有陸續有唔少嘅意外同埋死亡事故。大家睇到即係畫面14單嘅路九肚山，有位工人就用個 A 字梯跌咗落嚟。咁呢啲係老掉牙嘅問題。講緊 A 字梯呢啲高空工作，我哋講咗好多呢啲咁嘅事故。咁點解仲會繼續發生呢？咁我哋都要問一問，究竟大家點解會有啲事發生？咁另外即係好不幸啦，大家都知道喺9月21號，即係琴日有一單事故啦，喺洪水橋一個地盤，咁就有位工友咧，就喺即係以我哋所知啦，以報紙所睇到啦，就係喺度落緊一個即係 Precast 預製件嗰時啦。咁聽聞咧，佢係一個即係揸車個貨車司機嚟嘅。咁去鬆嗰個即係綁住個預製件嗰條帶嗰陣時，嗰個預製件就反咗，咁砸死咗佢。即係大家問呢啲係咪其實可以避免呢？絕對可以避免。但係點解又會繼續發生呢？我哋究竟即係咪好多時候都遺忘咗好多唔同嘅安全措施，有冇做到呢？尤其是喺一啲即係高危嘅工作，如果冇特別嘅監管，冇一啲人accompany去陪住去做，冇 supervision， 冇人監管嘅時候，係咪可以繼續做呢？好多時候我哋即係發生意外嘅情況，都係喺啲 lunch time 食飯前、收工前、放假之前出現嘅問題。咁我哋係咪即係其實作為管理層又好啦，前線嘅工友又好，大家係咪都要留意呢啲咁嘅情況 係咪特別應該要去注意咧？如果去到呢啲咁嘅地步，即係如果得一個人做嘢，或者係即係個時間係個地盤冇乜監管嘅時候，咁呢啲我哋都要反省睇下。咁呢個就係九肚山嗰個意外啦。咁啊，74歲一個裝修公司嘅老闆。另外一個就喺科學園啦，即係喺我哋上一次做完呢個Water Talk 之後，咁啊連續有2單，咁啊一單就係喺科學園嘅意外啦。咁啊究竟有冇斷電做嘢咧？究竟我哋嗰個 Permit to Work System 係點執行咧？大家會唔會喺個工地度，大家都應該再重視多啲，睇下點樣可以做好呢個電力工作咧？咁呢個就係琴日發生啦，咁啊真係相當唔開心，即係大家都睇到，大家即係嗰啲工友嘅年齡都唔係細嘅。咁究竟我哋喺安全方面仲可以做多啲乜嘢咧？主席都講咗好多次，我哋前線或者我哋即係所有管理層，其實而家喺建造業嗰個安全文化係非常薄弱。大家睇到喺8月，短短8月已發生咗4件嘅死亡事故。無論個事故嘅發生嘅原因係點都好，其實大家都要清楚理解到，而家我哋嗰個安全文化係真係非常脆弱。唔係我哋就咁話講完，有做咗口號就係算做咗嘢嘅。我哋其實係真真正正，即係好似主席成日講，我哋要行出安全，要落去地盤去睇每一個步驟，親身去同嗰個 real guy 同嗰個真正做嘢嗰個人講清楚個風險係乜嘢，做個動態風險評估，做之前評估下個風險係乜嘢。咁樣先可以真真正正令到個地盤做好安全，並唔係話我哋求其講2句就會去做到。咁所以大家真係要痛定思痛，我哋喺建造業，我哋點樣挽救我哋建造業咧？如果係咁樣不斷有咁樣死亡意外發生，我哋係唔能夠持續落去嘅。咁我都希望大家可以真係真真正正唔好當係口號，行出安全落地盤去睇下。咁仲有一個事故啦，頭先吊臂嗰度啦，第二就係喺中間道嗰個有一個地盤啦，連續喺1年之內都已經係第2次發生火警啦。咁大家都要留意，即係我哋真係要從錯誤中學習，要改善。如果有啲咩嘢之前係發生過嘅，當一個寶貴嘅經驗去學習。因為而家嚟緊就已經係就嚟秋天乾燥嘅季節啦，火警亦都係一個對於我哋建築地盤係好大嘅威脅嘅危害。咁大家如果係做一啲即係熱嘅工作，真係要真正要揾清楚，睇住完咗之後要檢查。因為如果一個地盤着咗火，好似上一次咁燒通頂，所有大家嘅功夫都白費。莫講話係咪即係如果有機會去牽涉到人命咧？咁所以咧今日即係都係有啲唔開心嘅。即係今日每一次 webinar 我哋都希望其實係上個月係冇乜即係意外發生，但係好不幸8月係有好多單意外。我希望大家即係我哋 CIC 或者同業界大家一齊努力，希望可以就將大家個安全意識繼續提升。咁我哋會繼續同大家即係一路都會去提醒大家，同埋做呢啲即係 webinar，令到大家個安全意識一路提高嘅。咁今日我講到就係咁多啦。咁多謝大家出席啦。我哋下一個月希望喺冇意外嘅情況再同大家見面。多謝大家。
唔該晒林先生嘅分享。而今日嘅研討會亦都去到尾聲。咁我哋下個月嘅 Water Talk 再見。多謝。